your patience. So thank you all very much for joining today on this panel, which is called Cable Operators Conundrum: How to Stay True to Your Cable DNA. My name is Jeff Hainan. I cover broadband access and home networking as an analyst for the Deloro Group. This is the first of a series of webinars that is going to be co-hosted by Casa Systems and RocNet Supply. And really, the focus here is to help cable operators sort through all these different options they have in front of them to evolve their broadband networks and deliver higher speeds, higher reliability, and greater customer satisfaction. So I'm moderating today, and I'm very happy today to be joined by two experts. The first is Peter Wolf, the VP of Product Management and Solutions Architecture from Casa Systems. Hey, Peter, how are you?
Great, thanks, Jeff, and to all that joined the call, hello, wherever you are.
Thanks, Peter. And then also joining us today from RocNet Supply is Jason Patterson, and he's the Director of Network Architecture. Hey, Jason, thanks for joining today.
Thanks for having me. Glad to be here.
So before we get underway, just a couple of quick housekeeping items. First of all, we want to make this an interactive webinar. We've got some slides, but we're going to be mainly focusing on discussion and your questions, of course. So please feel free to ask your questions in the Q&A box in the Teams platform. And then the second item here is that we're recording this webinar. And so we're going to send out the link to this recording to all attendees after the event. So check your email inboxes to be able to share that with your colleagues who couldn't attend today. So I think that covers it for the housekeeping items. Before we get started, I just want to set the stage and frame our conversation just really quickly with some overall market trends that we're seeing in the cable sector. So, you know, I think it goes without saying here in the North American market, at least with fiber overbuilders, fixed wireless providers, you know, cable operators are really dealing with some real competition, and that's something that cable operators have maybe not faced before. So, you know, historically they've dealt with battling ADSL or even VDSL, and now they're facing threats from both fiber to the home and fixed wireless providers. And so what those competitors are coming in and doing is saying, look, cable operators are the incumbents. They've got old technology, legacy technology. It's slower than fiber and less reliable than fiber. And of course, on the fixed wireless side, doesn't provide the same level of value. So, of course, to fend off these challenges, cable operators have many choices available to them to increase their bandwidth, reliability, and the overall performance of their broadband networks. In the DOCSIS 3.1 realm, they can do mid-split and high band splits to increase upstream throughput. One of the topics we're going to spend, I think, quite a bit of time on today is DOCSIS 3.1 Ultra or DOCSIS 3.1 Extended. And that's deploying additional OFDM blocks on their existing CMTS or CCAP platforms, along with upgraded CPE that can get you up to 6 gigs down and 1.5 gigs up. Of course, spectrum increases are available. It can upgrade to 1.2 in the short term as an interim step, potentially to DOCSIS 4.0. On the video side, operators are moving away from QAM-based video to delivering IP video in an effort to reclaim bandwidth. We're seeing that certainly a lot more in the case of Tier 2 and Tier 3 operators. For DAA, distributed access architectures, we've been hearing certainly a lot about that. Digital forward and return provides significant benefits in signal quality and error ratios. And of course, the transition to DOCSIS 4.0, we're certainly going to discuss that as well today. You know, when does that become an option for operators beyond the Tier 1 space? And so, you know, that's really why we're here today, is to kind of navigate these options and figure out which ones have pluses and minuses for your business. You know, I think it's important to note that all these options take advantage of the existing HFC footprint. And of course, you know, the biggest thing about that is that all these upgrades can be made at a fraction of the cost of overbuilding with fiber. And of course, really, at the end of the day, it's really clear that there are many years left with HFC, with all the upgrade options that they have available. So one of the things that I do is track investments in head end and outside plant equipment as well as CPE. And clearly we're seeing operators continuing to invest in their short-term infrastructure. And you know what I just realized is that I'm not sharing.
I say, you want to share slides, Jeff?
Yes, okay. See,
we said there's only going to be a few slides anyway. So there'll be even
well, there we
fewer
go.
now.
We've reduced the slides 100%. So I apologize for that. The other slides were text, so not really very critical anyway. But here again is some of the things that I track as an analyst, and you can see that operators continuing to invest in their infrastructure, whether it's DOCSIS licenses on their existing CCAP platforms as they do node splits and additional band splits as well. And then also ramping up their spending on remote PHY devices as well as virtual CMTS servers and licenses for additional capacity. We're going to talk a lot about vCMTS today as well. The last slide, which is only the second slide that you've seen, is the fact that we've heard a lot about DAA and remote PHY and vCMTS for a long time, and really it's interesting to note here that while the deployments are ramping up, that we're very much still in the early stages of this technology being deployed. Comcast and Cox alone account for roughly 40% of these RPD purchases on a global basis. They started their DAA journeys relatively early, and so what we're saying and what we're seeing, of course, is that the vast majority of upgrades for operators is still well ahead of us, and that's important to keep in mind as as operators as you're weighing when you begin your DAA transition as well. So that kind of goes over my initial slides, and hopefully that sets the stage for our discussion. So I want to open up the floor now to the real experts on the panel here, Peter and Jason. So guys, maybe we can go into again, some of these options that operators have available to them, and let's talk about maybe how they evolve. And Jason, I'm going to start with you and put up another slide here. Hopefully that works. And maybe you can walk us through how operators can maximize and evolve what they have in their networks today.
Sure. So what I was trying to capture on this slide is that there's a lot of life left in DOCSIS. The first thing I'll point you to is over on the left. You've got kind of the usage that we're seeing out in the networks today, and this is from like tier 2 and through 4 operators. On the downstream, typical usage today is anywhere from 3/4 of a gig to up to 2 gigs per service group, and then on the upstream, it's like 50 to 200 megs. So, and if you compare that to the right side of the graphs there, depending on what split you have and what kind of plant you have, there's a lot of runway from those numbers up to wherever you need to go. Now, some of those will require dropping video or moving to the DOCSIS 3.1 extended and things like that we're going to talk about a little bit later, or even DOCSIS 4.0 extended spectrum DOCSIS. But there's a lot of runway. So from where you're at today to where you want to be, there's a lot of effort in there. And some of the things that I see out, especially in the lower tiered market, is they have a desire to move ultimately to a fiber to the something premises, fiber to the home, whatever. They have a desire to move to that in the long term, but in the short term, they're opting to, hey, we're just going to let DOCSIS die, and we're going to build fiber. And while I'm not going to say that's a bad choice, that's probably not the best choice. And I think that one of the messages we want to get across on this meeting is, that doesn't have to be your options. It's not fiber or DOCSIS. You can do some of both, or sometimes it will make sense for one or the other. I'll give you an anecdote, sorry, and then I'll stop talking. An example rather. I did an install with a customer earlier this year. They had 450 megahertz plant. they upgraded to DAA and got all the benefits of DAA and didn't have to touch the rest of their plan. So it also doesn't even require to do plan upgrades even to take care of advantage of some of these things. All right, back to you, Jeff.
Yeah, thanks. Peter, maybe since Jason kind of provided an anecdote of what he's talking about with customers, can you maybe share some of the conversations you're having with customers as well, and what they're thinking about how they evolve in the competition that they're facing right now in the market?
Yeah, so thanks for that, Jeff. There's the customers that I've been visiting. A few of them have had, let's say, a 1 gig service for quite a while now, and if they didn't have that 1 gig service, they were challenged on their churns. They saw churns increasing, so they moved to the 1 gig, and now they're saying, what's the next step? Do I go VC cap DAA? Or can I get some more capacity out of the equipment that I have in the hub and the plant that I have, and what would it take to do that? And I think what we're going to talk about today is some of those things that operators can do to mine more capacity out of the assets that they have. And luckily, some of the ASIC suppliers out there on the cable modem side have come up with some new cable modems that will allow operators to do just that and push their speeds up into the 4 and maybe 5 gig range, which is very competitive with a fiber overbuilder, and they probably could use those speeds for quite a while before they go into some of the advanced architectures. So I think we're going to talk a little bit about that today, and how they make those moves.
Yeah, let's start by talking about this DOCSIS 3.1 Ultra, DOCSIS 3.1 Extended that we're really
3.1 Plus
within 3.1 Plus. Yeah, and it's got a lot of different monikers. And maybe you can, Peter, start by giving us some idea of what is required and what are the benefits that you get by moving to this DOCSIS 3.1. What are they going to need from an equipment and a software standpoint?
Sure. There's quite a bit to unpack there, but I think the key here is this is using 3.1 Plus, which is essentially adding more OFDM channels to the existing DOCSIS spec, which Cable Labs doesn't want us to call it, I think, anything fancy, because the Cable Labs spec for DOCSIS 3.1 says it's 2 OFDM blocks downstream minimum, and you may have more. And from what we've seen in the market so far on the cable modem side, that there's going to be cable modems that are essentially available with up to 5 OFDM blocks available. That's a significant capacity increase when you're thinking it's about 1.7 gig or so per additional OFDM block. So what we've been talking to customers about is in cases where they can use their existing CMTS and usually via a software upgrade, take advantage of the additional OFDM blocks in their downstream cards, or if it's a bidirectional card. And then, obviously you need to use these new cable modem, which from a timing perspective, from what I understand, the cable modem providers have had the RDK for these new chips for quite a while now, for at least 6 months or more. And the idea is these could become available in Q4 of 2024. So that gives you a rough timing of when that's available. And we're talking about, at least from the Casa side, doing some proof of concept lab testing with operators earlier in 2024 with those types of cable modems to test those new speeds out. So from a plant perspective, what we're also recommending is once you get past the sort of 2 gig kind of range, it's probably advisable to think about maybe a mid-split. So maybe you have to visit the amps and nodes out there and change some diplex filters, but that's largely to the extent that you need to do. Obviously, Jason was mentioning, if your plant is 550 or less, you'll have less opportunity to add those blocks. But if you have 750 plant, there may be spectrum planning that you need to do as well to achieve and utilize more OFDM blocks. So I think those are some of the areas that operators are looking, and they're sort of comparing that and saying, geez, if I do that, what's that cost on a per homes passed basis versus going virtual and DAA, which, there's a lot of benefits there. But, if you look at the cost on a per homes passed basis, especially versus something like fiber, I think it's going to be pretty attractive, and it uses, your existing assets for the most part. I'll pause and let you think about, because we kind of could go on and on about that topic alone.
Yeah, one of the questions that I've heard is, and maybe Jason, you can address this. If I'm an operator and I'm not at a gigahertz of spectrum, maybe I'm lower than that, can I still take advantage of DOCSIS 3.1 extended or ultra?
Yeah, you sure can. So there's going to be a couple of facets to that. First of all, as Peter alluded to, you're going to have to make some spectrum available. So whether that's rearranging where you put your channels or dropping video or things like that, you're going to have to make some room for it. But yes, my slide that I showed earlier, you've got quite a bit of spectrum available at 750 to add. I think it was almost 3.5 blocks of OFDM in there, which is going to give you a nice chunk of downstream bandwidth, especially if today you're only offering one or none, and that's going to be a huge difference. Aside from that, the other thing is, besides the 3.1, you also got the DOCSIS 4.0 modems that are coming out too. Those are a little bit farther along. You've got some other problems with those, but getting those rather. That's another thing too, is it's not limited to these new 3.1 modems. It's also going to be the DOCSIS 4.0 modems will be able to take advantage of that as well. The problem, of course, being with the DOCSIS 4.0 modems is they're behind the JDA, which, if you don't know about the JDA, Broadcom and the large operators partnered together to develop the DOCSIS 4.0 modems, and that allowed those operators to have exclusive access to them for a period of time before they're generally available to everybody else. So if you're a JDA member, you'll get DOCSIS 4.0 modems sooner than everybody else, but everybody else is looking at probably earliest 2025 mid, somewhere in there. I mean, JDA people have them sometime next year, but it's going to be, they have like the exclusive access to them for a period of time. And I think it's like a year. So it'll be a while before we see DOCSIS 4.0 modems out there.
And who knows what the cost of those will be as well, right? Maybe compared to a 3.1 plus, which is probably an easier ASIC upgrade, I would expect as well, and potentially more ubiquitous for operators to procure, and deploy faster as well. Go ahead, Jason.
Yeah. One other thing too is, even if you don't go to one of the new 3.1 plus modems or one of the 4.0 modems, even just having the multiple OFDM blocks that you can load balance across can give you a lot of bang for your buck, and you continue to use regular 3.1 modems, which are readily available. So that can also give you a lot of bang for your buck too. So I mean, it's not, you don't have to get the brand new modem, the newest, latest, and greatest, to take advantage of some of these changes as well.
Yep.
And Peter, along those lines, what kind of impact does the 3.1, the extra OFDM blocks, have on an existing CMTS? And then also, if an operator is considering this transition to 3.1 extended or ultra, what else should they know? Do they have to move to a vCMTS in order to make this happen?
So yeah, there's a couple of questions in there. So on the CMTS side, I think there may be some juggling of SC QAMs versus OFDM blocks that need to get managed. I know, on the Casa side, that's the only difference in number of service groups, and spectrum support that stays the same. So for the most part, that would be roughly the same, but you need to check with your CMTS supplier, and I don't know, the mileage may vary, but that's something to check with your supplier on. But for sure, you don't have to go to DAA or vCMTS to take advantage of 3.1. I think that's the other beauty of this. I think the expectation is there's potentially a lot of folks on the call here that haven't made that leap yet. So I think they'll be happy to hear that they could use, some of their existing assets to enable the 3.1 plus and get the benefits of these higher speeds before having to jump to fiber to achieve that.
So then I'm gonna be the devil's advocate there. On the other side of this, when you do move past 3.1 plus to DOCSIS 4.0, the one thing that you do need to be aware of is that's most likely going to be a DAA only technology. I don't think there's anything technically preventing it from being run on chassis-based ones, but I don't really see anybody developing a line card that does 1.8 or an analog node that does 1.8 at this time. It just wouldn't be cost effective. But if you're planning, if your ultimate goal is to get to extended spectrum DOCSIS at some point in the future, one of those steps to get there is going to be required to move to DAA, because that's the only way it's going to make that happen.
Yeah, that's an excellent point, Jason, and also a good segue. Maybe we should spend some time talking about DAA in general. The first in terms of the PHY layer capabilities, there was a time when remote MAC-PHY was a viable option for DAA. We see obviously with Comcast being committed more to remote PHY. Where does that leave remote MAC-PHY as a technology option within the DAA overall DAA landscape?
Sure, I'll start with that one. So there was there's a couple different flavors. When you say MAC-PHY, there's a couple different things that come to mind when you say that. So let's start with the Cable Labs specific one. So that's the flexible MAC architecture. The specs came out last year. So all of the major operators that were behind that have all switched gears to remote PHY for all intents and purposes. And so the development on that spec is done until another major operator comes to back it and put some time and money into it. That spec is done. So if somebody's looking to deploy a flexible MAC architecture, you're gonna, while the products are available, it got far enough along that the products are available, you got to make sure you come into that with the full knowledge that there's not likely to be any development further. So like the 3.1 Ultra or DOCSIS 4.0 on that path anymore, because all the people that were intending to go that way kind of made a decision about a year and a half, or I'm sorry, about 2 years ago almost, to go remote PHY. So that is the first thing. On the flip side of that, there are a couple other proprietary remote MAC-PHYs that exist that are still being developed by the respective companies, and they're still viable options. So because they still have it. Now, they still may not have the upgrade path to DOCSIS 4.0, but they should have all the other development there. And when to use MAC-PHY versus remote PHY is going to be kind of really the question. But the way that I think of it is, if you have a traditional cable architecture, like where you have all of your nodes coming back to a main head end, something that's going to be way more suited for a remote PHY type of deployment because it's already set up perfectly for that. On the flip side, if you have a bunch of little isolated hubs with 3 or 4 nodes that aren't interconnected, that may make a little more sense for MAC-PHY, because it's less equipment involved. You have an internet connection at each location. You don't have to bring it back anywhere central. Sometimes a little bit simpler. So there's times when it's still usable and still not, but for the most part, most people, I think, at least most of the large operators, have all made the decision to go remote PHY.
The only thing I would add there, I think I agree with Jason on the proprietary solutions. You're probably okay. At least there's a supplier you can talk to. You probably get support, get changes done. But if you go to a supplier that's down on the ASIC route, getting support from the ASIC supplier could be a challenge there. If they say, hey, there's no market, we don't want to do any more, firmware development on that version of ASIC, et cetera, because the market sort of just collapsed. That could be a challenge. So it's, I guess, one of those buyer bewares, as long as you're going into it eyes wide open. But I agree with Jason, there are architectures where it could make a heck of a lot of sense. It's just, you've got to really scrutinize your source and how you see future support for that product.
Yeah, thank you both. So in addition to the DAA nodes, either remote PHY or remote MAC-PHY, I always get a lot of questions around virtual CMTS and whether, what does that architecture look like for me as an operator, but also, what is there a requirement to put that, locate that in the cloud? What can I host locally? And Peter, maybe you can, I know you have a couple of slides here. Maybe you can walk through some of these architectural options. I'll put these up.
Sure. I think the first one is is that the centralized? Yeah. So the first one, yeah. So this is a typical centralized architecture of VCCAP with remote PHY nodes. To try to simplify this, the VCCAP we're showing on the far left, that would typically, but doesn't have to be, could be in your hub site. And you can think about VCCAP, if you have a CMTS today, as made up of a couple of functions, a control plane function, data plane function. And Casa has this in a couple flavors where actually control planes can be coexistent with the data plane on a server, or they can be separate the way we're showing it here. But the idea is the control plane is similar to the function that you'd have in switch cards in the CMTS. And the data plane functions are what you typically have like in a line card in a CMTS. So that's kind of the high level architecture of VCCAP. And a VCCAP versus a vCMTS, a VCCAP is basically an ICCAP. So in other words, it's a fully integrated virtualized CMTS, meaning it supports video, voice, and data. All three of those, not just data. Typically, these servers are tied together with some top-of-rack switches. The other beauty of this architecture that we're showing here is this VCCAP has switching and routing built in, so you can use very simplified, low-cost top-of-rack type switches. And those would all be connected to your network side production routers on the left-hand side of this screen, so it's sort of in that orangey color. And then as you go through the IP network, you're going to meet up with that's IP as well as these switches that we're showing here on the right is what's formed as the CIN network. That's a Cable Labs term for this type of an architecture. It's the Converged Interconnect Network. It's just a fancy name for the switches that connect VCCAP to the RPDs themselves. This is the centralized case that we're showing up here. And just to sort of bring in the cloud, some people are looking at saying, well, hey, can I put in multiple instances of these VCCAPs to support large numbers of remote PHY nodes that you'd see over on the right? And maybe I'd like to put that whole control plane function in the cloud. So that's kind of how that would be separated out. We've worked with an operator that's done that once with ABM, Google Anthos on bare metal was what we tested with. But essentially, that's doing as a cloud-based solution. So there are some operators that are interested in doing that. But what we find right now is they're first looking at VCCAP in situ in some location, in some cases trying to deliver it as an appliance. So in the next slide, if you go to that one, Jeff, this is the distributed case. There's customers that essentially say, hey, for each one of these hubs, I'd like to just run with an instance of VCCAP right there. To give you an idea, 2 servers with a high availability situation like you were showing here can do about 120, 130 MAC domains in that configuration right there with about 180 gig per RU or per server. So it provides a nice architectural option. And then Casa has in the middle here in the blue, we have an intelligent access controller that does provisioning, monitoring, and real-time telemetry to support these remote RPDs. So that's kind of the high-level architecture of VCCAP.
Yeah. So I'd just like to add a couple things on there. You don't need to put the slides back up, but a couple things is, the centralized one, you can kind of think of it as just CMTS replacement. Okay, I have one CMTS, I'm replacing it with virtualized version of it. Whereas the distributed one is, hey, I'm going to replace my line card with a server and go put that out somewhere. And I think that I've had a lot of success explaining the difference between those with customers. The idea is With the distributed one is you're putting it a lot closer to your customers and you're lowering their latency and all those fun things too, and allowing a lot better experience for your end users.
And one question that I've seen from operators really is, can they make this transition to DAA and get those benefits without having to make wholesale changes to their outside plant? Maybe Peter, we can start with you on that question.
Sure. So some operators, instead of putting a DAA node out there, have opted to actually use a remote PHY shelf. So a remote PHY shelf is essentially moving that DAA node into the hub site and connecting that node to the existing RF equipment. They have been significant gains in end-of-line performance, 6 to 8 dB MER by doing that. But you do need to have some type of a virtualized CCAP system in that hub site running that remote PHY shelf. But it's a way for operators to, without going and modifying their plant, to sort of get into DAA, try it out, try the virtual CCAP system, decide on distributed, decide on centralized, and look at the performance they're getting and start to operationalize it, because a lot of this isn't just the sort of the physical work, but it's also integrating the vCCAP into their back office systems. So, it's a way of getting started in that area without changing sort of too many things at once and still trying to get the benefits and the learnings.
And then also on the flip side of that too, I'm going to add, where you're talking about an operator that's generally going to have the lower spectrum available on their plants, like the 450, 550, even 750 plants out there. They're going to typically have a traditional analog node out there that's still only got one downstream service group, one upstream service group. Even by just replacing the node and going DAA, you can go to a 2x2 or a 2x4 node right there, and you get like a free node split as part of the process. By just replacing one node, now you've doubled your amount of bandwidth or quadrupled it in the terms of the upstream bandwidth by just replacing the node. You didn't have to touch anything else in the plant other than just replacing the node. And if you have a newer node, like say one of the 1.2 gigahertz nodes out there that are still analog, they actually make plug-in modules that you can get. They turn that 1.2 gig analog node into a RPD, and then all it is just a module replacement and about 4 different cables to plug in. It makes it really simple, and it's a very cost-effective solution. And again, you get the same benefits as now. Now, typically those ones will have more than 1 by 1, but you'll get at least the benefits of all DAA by just changing out a module. You can do that in an hour and be all set and done without having to splice anything in and stuff like that.
I think the key for a lot of what we've been talking about is, these things could be done incrementally at a phased approach, as sort of the budget allows, and get some serious benefits just by putting in a remote PHY shelf. You should be able to improve modulation depths a couple of orders. Usually, from what I've seen, 6 to 8 dB MER from what customers have reported back to us. So that could be significant from a competitive perspective in offering some new speeds to customers.
And when an operator is considering this transition to DAA, what are some of the questions that they need to ask the suppliers that they're looking at working with? Jason, maybe we can start with you on that. What are some of the considerations they really need to think about?
Sure. So the big thing they need to first figure out is, where do they, like, how much do they want to do DAA? It's not something you have to, like in the past, like if I'm going to replace my CMTS, I have to go in one maintenance window and change everything out and be done in one night, right? As Peter alluded to earlier, you can definitely do it piecemeal. But with this technology, it's not something that you have to do everything all at once, or all in total. You can cherry pick nodes service areas where you have have your highest usage and start doing those and really roll into it. So the first thing you want to find out from your supplier is, how many nodes can I put on a server, or how many how many service groups can I put on a server, how much bandwidth it's going to be able to do, what other ancillary equipment am I going to need for it, some of the things that come when you make the change to DAA that you've got to take into account are out of band signals. If you're going to keep your broadcast video, you need to be able to get that out to the nodes as well. You need to keep all those kind of things in. So you need to work with your supplier to make sure that they support all the types of things you're going to do. And then the last thing that I would say is really important and lots of times gets overlooked is, especially when you're moving to DAA, all of that physical layer that typically was in the head end, where you could have a head end tech go plug in a spectrum analyzer and look at return path monitoring, or check levels and stuff like that. None of that's there anymore. Now it's all out in the field. It doesn't exist anymore. So you have to have some way to monitor especially the return path and do things like sweep and stuff like that. So those are really big questions you got to ask your supplier is, how am I going to do my day-to-day operations? Turn that over to you, Peter. I'm sure you got something.
Yeah, you covered quite a bit of the things. I was going to say the test tools I think are important, and then the provisioning and monitoring piece of those is going to be important. And do those provisioning monitoring tools, can I integrate them with the CMTS I have, or the analog system, the system I'm using to monitor my analog parts as well? So I find that the back office piece of that could take some time to to achieve parity with where they are today, where the operator is working today in terms of the monitoring. That's some of the things lately we've been having discussions with customers, is just how do you get that done, and what parameters do operators need to monitor, and how does it sort of meld in with the existing key parameters that they're monitoring today. So I would say that's some of the things, as well as even more simple things like what analog nodes do you have today, and then does your future supplier support the different node types? We know there's many out there, which can be upgraded. What are you going to get after is upgraded? Is it full 3.1 or 1 gig capable or 1.2 gig capable? What's it going to be? So I think that that's probably the other piece as well.
And Peter, when you've talked to customers who have made their decision to move to DAA, what's really been some of the driving factors to do so? When we've talked to operators, in some cases it's the additional telemetry. In other cases, it's the age of the existing CMTS, and in some cases it's been competitive dynamics. Has there been kind of a uniform driver, business driver, technical driver that you've seen in talking with customers?
Well, I think sort of how we started this whole conversation, we see operators really starting to be concerned with not being able to get these new higher double-digit gig speeds as something in their future. And that's one of the drivers, and that's why we were talking about 3.1 plus as well as another alternative. But before 3.1 plus, I think DAA was definitely what they saw as the tool in the toolbox to apply to that. But there's other things that the DAA architecture can provide, in that people thought that was more eventually going to be the end game. In other words, we were going to go to DOCSIS 4.0, and I think the thinking was we only want to touch our plant once and then let these nodes sit for another 15 years or so. And I think that was the other piece. These, a lot of the nodes that have been out there, like Jason was talking about, are sitting in either 450, 550 plant, and they have to look at, how much longer is that equipment going to continue to operate reliably before they, have to make a move. So I think that's a piece of it as well. And it's not just the nodes, right? I mean, you're talking about amplifiers as well that would probably need to be touched. So I know there's a desire to try not to touch the plant, too many more times, but that's a decision operators are going to have to make on their own on a per homes passed basis, and what they're seeing for competition and how it's affecting their churn.
And Jason, maybe in your discussions and also your work with operators, have you talked to operators that have been successful with DOCSIS and competing with fiber overbuilders, and how have they done that? What's been the set of tools that they've used to compete successfully?
Well, typically, like when you're talking fiber overbuilders, they're usually getting money from like BEAD or one of the fiber incentives from the government, and so usually to qualify for one of those, you got to be an unserved or an underserved area. And so the very first thing you want to do if you're an operator that could fall into one of those ones is you want to get out of that underserved areas classification so that you're not attracted to them. So the very first thing is you got to raise your billboard speed. So the ones that are being targeted by overbuilders are probably two places. One where it's really dense and urban, because the fiber overbuilders can get a ton of potential customers. And then the other one is places where they don't have any other alternatives or any good alternatives. So I think the very first thing you want to do is make yourself a good alternative. And I think the bare minimum in 2023 to qualify for that is to have the ability to do gig services. I mean, that's not the government one, but that's the consumer expectation is you got to have at least
Kind
gig
of table
services.
stakes, right?
Yeah. Yeah,
It's
so you got
becoming that
to
way.
have like at a bare minimum, you got to be thinking, okay, I got to get gig services. So if you don't have gig services today, that's the first one. So I've definitely helped several operators make that transition. If you've got a first generation or second generation CMTS, one that's end of supported for a long time, you're probably in that camp. You may be able to offer gig services, but they're probably not the greatest gig services. You probably want to get out of that. And so I've helped several operators move from aging technology, let's call it, to DAA, and they get all the good benefits for it. So I've done some planning work for when I talk to these customers, and I kind of laid out. Sorry, I didn't put it on the slide, but I laid out like a typical CMTS with all its ancillary equipment, like transmitters, receivers, return path monitoring, combining, etc. And if you take a typical current generation ICMTS and put it in a rack with all of its stuff, it's about 2 racks worth of gear for one CMTS altogether. When you make that switch to DAA, all of a sudden that goes down to about 5 or 6 RU, depending on what maybe a little bit more if you had video in there, but quarter rack max type of stuff, and you get all the same capabilities, way less space, way less power, most importantly, way less cooling, because that's a big thing, especially in some of the operators I've had, where they're in really hot places. Now they don't have to pump a ton of cooling in to maintain multiple CMTSs. Now they've just got a couple servers. They can get it all in one little space. So that's a big one. But then you get tangible benefits, things become easier. One of the things when I worked for the operator side of things that really frustrated me when we were trying to troubleshoot customer problems is we would be troubleshooting noise and things like that. And we'd have field guys out in the field and they'd be tracing all the way back to the node and they couldn't find anything. They weren't seeing anything. And lo and behold, we've come to find out it was something in the head end. Somebody was doing some work totally unrelated, bumped a cable and broke the fitting or something and was causing ingress or something like that. And all those kind of problems go away with DA because none of that plant stuff is in your head end. So one of the things that the field guys really like is, hey, if there's an RF problem in my plant, it's actually out in the field. It's not going to be in the head end. I'm not going to have to go chase ghosts in the head end because those kind of problems tend to be very difficult to find, and it's usually like the last thing you're thinking of, and you've tried everything else first. So those kind of problems operationally kind of go away, and I've helped numerous customers with those kind of issues.
So we've got about 10 minutes left here. We'd love to get your questions. So go ahead if you do have a question for Peter and Jason, just go ahead and type it into the Q&A box. Fire at will whenever something strikes your fancy, and we'll certainly get those answered for you. As we wait for some of those questions to come in, we've spent a lot of time talking about HFC and DOCSIS, but I mean clearly operators are doing greenfield build-outs with fiber and using PON, and I mean that's certainly well known. Is there a way, Peter, for DOCSIS and PON to coexist in the same network?
Sure. So operators have been doing that today in specific cases where they've been using a DOCSIS fiber node and then maybe adding a Tibit stick or something like that to service either businesses or high usage type customers to allow for a coexistence. And the nice thing about that as well, we're talking about virtualized systems. There's a virtualized VCCAP. There's also virtualized BNG that you could use in that type of environment. Again, another function that would just be virtualized and live on a server, in the hub site to support those types of coexistence deployments with fiber as well, DOCSIS.
Yeah, some of the other things too. A lot of those, some unnamed large operators have gone that particular path, and the strategy seems to be that what they're going to do is ultimately they want to at some point in the future be a fiber only network, and they want to get rid of HFC. And this is a long-term solution. And so the idea is they're going to go and find their high usage customers, and they're going to build towards them, and start building out the PON network at the same time they operate their DOCSIS network. And that's a very valuable strategy because, every time you pull one of those high usage customers off, you free up all of the other HFC resources that they would have been using to do tons of traffic for all of your low usage users to have a much better experience. So that's a very, very good strategy. And there's another part of that too, and I'm going to bring it back to cable a little bit here. Sorry, I'm a big cable guy at heart here. You get you can do kind of the same thing. You can add another component to that, especially if you are at a lower spectrum like 750, 860, those kind of spectrums below 1.2, because when you put the node out in the field, all of the DAA nodes are 1.2 nodes. 1.2 gigahertz nodes. And so clear up until that first active, you have a 1.2 gigahertz network. Now, as soon as you hit that first amplifier, it's going to be whatever your plant is. But you can start, you can add additional spectrum for just those customers that are near the node. Then you can also kind of offload on using D31 and kind of get the same benefits before you even go to PON. So there's like another step that you can take in there and start getting some of those benefits, especially if you're one of those customers that still has a lower plant capability, so that you can like cherry pick the people that are close. Now it's limited; it's not quite as much as PON. You can't really do as much as what we were talking about before, but every little bit helps when you're at the you got a 550 plant or 750 plant. There's not a whole lot there to work with.
Yeah, and to springboard off of what Jason's saying, I mean, if you find the economics work out where you can pull a fiber into an industrial park, first of all, the fiber you put in is probably 48 count or more. So the idea is you pick up that customer and then you go try to pull in as many others as well as you can off of that fiber cable. So at that point, then the economics start to really work in your favor once that's done. So that's always a benefit. Just remember, operators don't pull just one fiber. It could be 48, 96, 128, et cetera count. So it's a good thing from a network and enhancement. Brings a lot of value to the network.
Yeah, I like that. One last thing here. So the other thing too is switching to DAA also frees up your fiber for other things besides PON. PON's one other use for it, but you can do cellular backhaul. You can fix wireless access. You can do all kinds of other things because now your whole fiber is not being utilized by the proprietary HFC technologies of the past. So it freed it up to do other things. Maybe you're gonna go and do put a node a little farther in, and now you can just drop a wavelength off there instead of having to pull a whole nother fiber all the way out there. So it enables a lot more things than just DOCSIS capabilities. It's some of these operators start to become MNVNOs, things like that. All those things become possible because they have a Ethernet network that powers it rather than a DOCSIS network that powers it.
And if they go with the distributed type of VCCAP, now you've got more edge the compute at the edge. Back to the benefits you were talking about earlier, Jason, with the lower latency, et cetera, which is be pretty important for the cell backhaul piece of that.
I see a couple questions on here. I don't know if you can see them, Jeff. So
I'll answer. I can. Let's get to those really quickly. Before we migrate away from PON and go back to DOCSIS 100%, there's a question that came in about how options for managing a DOCSIS and PON, and how do you do provisioning using the same management software? I'll open it to both of you.
I'll take that one. So
okay.
one of the really interesting things that you can do, especially with DAA, is you can kind of merge the two technologies, a DOCSIS network and a PON network together, and have the BNG be the source of truth for it. So BNG, if you're not familiar, and cable people don't generally know that term, it stands for Broadband Network Gateway. Typically, that would be used for the customers to connect to. It's the customer's gateway in a fiber network is its typical function. Other than that, it has similar CMTS functions like lawful intercept, subscriber management, bandwidth management, and stuff like that. And so by using a BNG to be the bandwidth manager for your network for both technologies, you have one place where you can provision not only PON subscribers, but DOCSIS subscribers, and have one place where you can go and look at statistics and do lawful intercept and things like that. There still is some integration work that needs to happen to make that 100% reality. You can do part of it today. The big challenge is on the upstream side of things. The downstream side that's doable today. On the upstream side, though, there needs to be a tie-in from the BNG, which authenticates via radius, to the VCCAP, so that when the radius server gives speeds to the modem, that the modem adjusts its speeds. And there's mechanisms to do that, but there's some development work going on right now at Casa Systems and other places to make that kind of thing happen. And then you have a converged wireline network.
So I was just going to add on there, another benefit to having that single source of truth is that's where you could, if you are running out of IPv4 addressing, you can do CGNAT in that location. So now you can increase your address space, and you don't need to go out and purchase addresses because that BNG typically would have that function as well built into it.
All right, so another question that we had come in was with respect to DOCSIS 4.0, and we didn't spend a whole lot of time on it, but obviously the theoretical speeds for DOCSIS 4.0 are 10 gig down and upstream of about 6 gigs. The person was asking whether the upstream part of that of the equation is going to be challenging for this CCAP or VCMTS.
I don't think it's going to be challenging. I'll take that one. Sorry. I don't think it would be too challenging because the real problem on the upstream side of things happens at between 108 and 204, because that's traditionally where your out of band signals are, and working around those is generally the problem you have. When you get to the higher splits of DOCSIS 4.0, which can go all the way up to 684 megahertz, that plant's going to be generally clean. Now, the one challenge you are going to run into is now you've got to go sweep all this for return instead of for forward. But you shouldn't have too many challenges with that and benefits. But again, that requires the move to DOCSIS 4.0. You got a lot of runway before most people are going to need DOCSIS 4.0. I know people want DOCSIS 4.0, but you still got a long ways to go from there. But the upstream side of things, I don't think there's going to be too many challenges there. Because one of the things that they've done in the spec is they've made it so 5 to 204 is existing DOCSIS networks, like up to DOCSIS 3.1 only, and then it's from 204 up that's the new DOCSIS 4.0. So it becomes a little bit easier separation in that regard.
I would just say that the CMTS is probably going to be the legacy CMTS is going to be limited at 3.1, 1.2 down, 204 up. VCCAP doesn't care as much. It's really a throughput machine. So it's really about data throughput on a per data plane basis. So it doesn't care as much about what the spectrum is. That's really managed at the node. So the VCCAP part of it is easily adaptable to that. And if you're to the point where you're offering 10 gig and you've got significant penetration, it's as simple as adding another data plane server to that type of a complex to manage additional capacity, and it automatically load balances across those different servers.
And Peter, we'll close with the last question for you. Start with you on this one. How about low latency DOCSIS? We didn't get a chance to talk about that yet, as yet another tool that operators have at their disposal. But how does low latency DOCSIS work in the 3.1 environment?
Okay, so low latency DOCSIS, there's actually multiple mechanisms that some operators are started to look at. First is automatic queue management, and that's one method that they're looking at to try to, and that's usually built into the CMTS, where you can set up a queue size and how long delays will be. The other thing we've been talking to operators about is just doing proactive grant servicing. So that's something you can do again in some of the existing CMTS as well as VCCAP. So you don't need to do VCCAP to get low latency DOCSIS. That's something that should be available in the CMTS. And there's multiple mechanisms in there for handling non-queue building and queue building flows or standard flow types. But the way I look at it is it's typically the way operators have started is to do this in stages, doing AQM, automatic queue management, and then moving on to maybe looking at proactive grant services. The nice thing about sending out grants to cable modems is it doesn't matter whether they're 3.0 or 3.1 cable modems. It kind of floats the boats for everybody. So when the tide rises from those, and Casa has done a lot of testing that shows that it doesn't take a lot of extra grants to get improvements between something like down from 12 milliseconds to single digit milliseconds. So that's we're seeing a lot of improvement and promise there, and operators starting to test those mechanisms, as well as some additional ones in low latency where you have to either tag the traffic or you need to specify the source IP address and have those packets treated differently. But I think it's going to take a while before we utilize all of low latency DOCSIS, but there's a interop group that we've been participating with, L4S, which essentially brings in application providers like Apple and Microsoft, and trying to ensure that DOCSIS, the features in DOCSIS with regard to low latency actually improve the application and the subscriber experience. So that's an ongoing effort, and many operators are kind of in the middle of starting to do more and more testing in that area.
Well, great. I think we have now we've exceeded the top of the hour here. We did get a little bit of a late start, but I want to thank Peter and Jason for all of your insights today. Thank you guys very much. And then also I want to thank all of the attendees for your participation as well. Just keep an eye out in your inbox for the link to this recording. And then also keep an eye open for the subsequent webinars that we plan to do here as part of this series. And with that, I'll close today. I want to wish you all happy holidays and a happy new year. Take care.
Thanks, Jeff, Jason.
Yep.
Happy
Thanks,
holidays.
Peter and Jeff. Happy holidays to everybody too.
Take care. Thanks all.